So in section 5.2, we have equations that have variables on both sides of the equation. So, for example, I could have an equation like this. 12x minus 3 equals 4x plus 13. Now, the problem with solving this is obviously it's hard to find out what x is when you have more than one x. So our first step needs to be what, do you think?
Combining 4x and 12x.
Okay, we need to combine the 4x and 12x, but there's a problem with that. What's the problem with that, Olivia? Okay, right. One is on the left-hand side, right, and the other's on the right-hand side. So I can't just add them together. Brush?
You can move the 4x to the left and make it negative 4.
There we go. All right, we can solve an equation. What is 4x? 4 times x, but what is 4 times x? We don't know, but we know for sure it is something, right? And here's the thing. No matter what 4x is, no matter whether 4x is, 4 times 3 and it's worth 12, or whether 4 times x and x is 2 and it's worth 8, whatever it is, I know for sure that if I take 4x away from 4x, it's going to leave me with 0. Okay? The nice thing is that even though we don't know what 4x is, we know for sure that it is some number, and that means if you take it away from itself, you're going to be left with nothing, right? Our main rule with solving equations is whatever we do to one side, we do to the other. So we can subtract 4x over here as well. Now remember, you can only combine like terms, so don't subtract 4x from negative 3 because that won't work, right? Not like terms. We're going to subtract the 4x from the 12x because they're like terms, which leaves me with 8x minus 3. The 4x minus 4x leaves me with 0 plus 13, so I'm left with 13 on the right-hand side. And now what does that look like? That's just a two-step equation now, right? So from here I'm going to add 3 here and also add 3 there. Those cancel out and I'm left with 8x equals 16. And then final step, we're going to divide by 8 on both sides. And so we get x equals 2. Now, one thing I want you to get in the habit of doing now as we're moving into the more difficult equations is I want you to check your answer. So to check your answer, all you need to do is take your original equation, 12x minus 3 equals 4x plus 13, and replace x with 2. And make sure that it actually works. So let's do that. So I'm going to do the check here. So my equation was 12x minus 3 equals 4x plus 13. We said x is going to be, where'd it go? Well, that's weird. My slide went away. All right, we'll have to just rewrite it. 12x minus 3 equals 4x plus 13. My solution was that x equals 2. So I'm just going to replace x with 2 in here. So I have 12 times 2 minus 3 equals 4 times 2 plus 13. So now you've got order of operations problems on each side. So on this side, the first thing I do is multiply. So 12 times 2 gives me 24. So I have 24 minus 3. And on this side, I have to do the multiplication. 4 times 2 is, so I have 8 plus 13. 24 minus 3 gives me 21, and 8 plus 13 gives me 21. So the two sides do in fact come out equal if I let x be 2, which means my solution is x equals 2, right? So that's how you do a check. It's just a matter of plugging in what you think the solution is into the equation and making sure that it does in fact equal out. All right, now let's look at another example. So let's say I have 7 minus 4c equals 3c minus 7. Now, once again, our first step is we need to combine those like terms. But since they're on opposite sides, that means I can't just do negative 4c plus 3c. What do I need to do? What do I need to do? I know y'all aren't awake yet, but I mean, somebody's got to know. What are we going to do? How are we going to get them together? Megan? Minus 3c. Is it positive or negative? It's positive, so that means to get rid of it, we need to subtract it, right? If it's a positive number, we subtract to move it. If it's a negative number, we add, right? Yes?
Can we, like, to solve it, can we just rewrite the equation with the like terms next to each other? Like, if it's negative 4c, we rewrite it negative 4c minus 3c equals.
To show your work, I want to show that the original equation and that I am subtracting 3c from either side. But that's essentially going to do that. Now I have 7 minus 4c minus 3c equals negative 7. Is that what you're asking? Like, can you just skip straight to this equals negative 7?
Instead of like subtracting it like that, just rewrite it with the like terms next to each other.
I really want you to think of it as doing inverse operations for right now, because it's not really, I mean, they're like terms, but they're on opposite sides, so you really need to know that the reason, you need to show the reason why you're switching it over right now. So for right now, I want to stick with write the original equation, show that you're subtracting from either side. But that will get you the correct answer. I just want you to get in the habit, though, of showing your work, because as a teacher, I want to see your thinking. I don't want you to jump and then I don't know if you knew what you were doing or if you just kind of happened to get the right thing. All right, so from here, those of course will cancel. So on this side I have 7. This is negative 4c and negative 3c, so that makes negative 7c. Remember, if you think about minus signs as negatives, then it's always addition. So negative 4c and negative 3c added together makes negative 7c. And then I'm left with, negative 7. Do not lose those negative signs. So I'm left with negative 7 on the right-hand side. Well, let's do something just for a second. That's a common mistake, right? People losing negatives. So let's make a mistake on purpose for a second here. So let's say we get positive 7 here. Then my next step would be to get rid of this 7 over here on the left-hand side. So I'm going to subtract it, because remember it's positive. So I'm going to subtract 7. That cancels, and then I get negative 7c equals 0, right? And then I divide by negative 7. And 0 divided by negative 7 is 0. So I get my solution as c is 0. Now, of course, we know that that is really wrong because we did it wrong on purpose, right? But let's see what happens when we do a check now, knowing that our answer is wrong. So let's take our original equation I'm going to leave it on this same page so that we can see it more easily. So my original equation was 7 minus 4c equals 3c minus 7. I'm going to replace c with 0, so I get 7 minus 4 times 0 equals 3 times 0 minus 7. Order of operations says I do the multiplication first. So I get 4 times 0 is 0. So I get 7 minus 0 equals 0 minus 7. Well, 7 minus 0 is, and 0 minus 7 is. And here's what happens if you do a check and your answer is actually incorrect. You get two things that are not equal. And then that tells you, it doesn't tell you what the right answer is. All it tells you is that what you have is wrong. And then that allows you a chance to go back and go, okay, well, where did I make a mistake? Well, let's see. If I look back at my equation, okay, I subtracted, and that's right because that's positive, so I subtracted it. And negative 4 and negative 3 makes negative 7, so that's right. And then, oh, wait, look, that's supposed to be negative 7. So it gives you a chance to go back, find where you made your mistake, and fix it. Now, once we fix that, of course, then we know negative 7 minus 7 is not 0, it is negative 14. And then negative 14 divided by negative 7 is not 0, it is positive 2. All right? And then if we wanted to go back into our check, we could just replace our zeros with 2's. Ooh, that's a big eraser. Trying to erase without erasing everything. All right. So we're going to replace that with 2's. So times 2 times 2. So now we get 4 times 2, which is 8, and 3 times 2, which is 6. And I get 7 minus 8, which is negative 1. And I get 6 minus 7, which is negative 1. Now my check does work out, so that tells me that C equals 2 is the correct solution. So you see how a check can help you. It lets you see if you made a mistake, and then if you make a mistake, it gives you a chance to go back into your work and try and figure out where you messed up so you can fix it. All right, we're going to do one more together, and then I'm going to give you some time to start doing some in class. So, let's see. Let's look at number 3. All right, so this one here. There it is. All right. So let's say I have 7y plus 25 equals 2y. Now, what's my first step to solving this one? Felsen?
Minus 2y.
Minus 2y. Now, I'm going to subtract 2y from this side. I'm going to subtract 2y from the y term on this side. So I get 5y plus 25 equals 0. Now, there's actually an alternative to this, and I'm going to show you real quick that it just comes out the same. If I take this same equation, 7y plus 25 equals 2y. The one thing that was a little different about this one is that the y term on the right is there all by itself. Now, one thing you can do, if you would like, is we keep moving things over to the left-hand side. You can actually subtract 7y from both sides and group your variable terms on the right. Now, personally, I don't tend to do that because I'm a little OCD and I like my variable on the left and it just makes me feel better. But if you want to, I would just want to show you that we'll get the same thing. If we do this, then I have 25 equals, and 2 minus 7y is
Negative 5y.
-5y. Now from here I'm going to divide by -5. The advantage to this is now it's only, instead of being left with a two-step equation like we are here, I'm left with a one-step equation because I don't have any constant term on that side, right? So I can just go straight to the division, and 25 divided by -5 is,
Negative 5.
so I get -5 equals y, or if you're like me, y equals -5, okay? Now, on the other side, I would need to do what to solve this one here?
Subtract 25.
I can subtract 25, and that means I also subtract 25 over here. On this side, I'm left with 5y, and on this side, I'm left with -25. So here, my 5 is positive, but my 25 is negative, whereas over here, my 5 was negative, but my 25 was positive. So in the end, the final answer is going to be y equals -5, right? Same solution either way. So if for whatever reason you really would rather group your variables on the right-hand side just because it's easier to work with, whatever, you can do that. It doesn't make any difference at all whether you group your variables on the right or whether you group them on the left, unless you're like me, and then it just makes you feel all funny inside that the variable's on the right. And then, which even then, I could have just rewritten it as -5y equals 25 and gone from there. So you can group on the opposite side if you would like to. Same solution either way that you do it. And of course, we can check our answer really quickly. So 7y plus 25 should equal 2y, and we said y is -5, so I have 7 times -5 plus 25 equals 2 times -5. Order of operations says we do our multiplication first. 7 times -5 is -35 plus 25. And then multiplication over here, 2 times -5 is -10. And -35 plus 25 is -10. So I get, both sides do come out to be -10. They're equal to each other. So my solution, y equals -5, is correct, right? Okay, your homework tonight is from the textbook.